video, we're going to be talking about properties of parallelograms, a special type of quadrilateral. So let's start off with those properties. There's 5 main properties here. If you're following along in your notes, go ahead and draw these symbols that correspond with these properties. The first thing is that we're going to say that opposite sides are parallel. So side LP is parallel to side MO. We're going to say that they're parallel with symbols by using the same arrows going the same direction on both segments. Also, LM is opposite from PO, so those opposite sides are also running parallel. We'll give them arrows as well. Second property, opposite sides are congruent, so again, opposite being across from. Those two sides, LP and MO, are the exact same length. We say that by putting a little hash mark representing the same length. Also, LM opposite from PO, those opposite sides are the same length. They're not going to be the same as the left and right side though, so we're going to give them an extra hash mark. Third property, opposite angles are congruent. So angles that are across from each other are going to have the exact same measure. So angle P and angle M measure the same. So we're going to give them arcs to symbolize their congruency. Also, angles L and O are opposite, so they're going to be equal in their measures. So again, give them the same arcs. Angles L and O are not going to be the same measure as P and M, so make sure you give them different arc symbols. Property number 4, no special symbol for this, but we know that angles that are on the same side, angles that share the same side, or also known as consecutive angles, they're going to be supplementary, meaning they add up to 180. So this measurement for angle M and this measurement for angle O are going to add up to 180 degrees. Any consecutive angles or same side angles are supplementary, so that means that angles P and O are both going to add up to 180. Angles L and P are going to add up to 180, and finally angles L and M are going to add up to 180. So any angles on the same side are going to add up to 180 degrees. Lastly, property number 5, in a parallelogram, the diagonals are going to cut each other in half. So this diagonal running from P to M is going to cut this diagonal LO in half. So this half right here is going to be congruent to this half. And LO did the same thing to PM. It cut PM in equal halves. So this half right here is going to be congruent to this half. Be careful, there's a common misconception. These diagonals are not congruent. So these two halves are not congruent to these two halves. As it turns out, because this shape is pushed over or leaning slightly to the right, this diagonal is going to be slightly longer than this diagonal. So when we cut them in half, we don't get equal halves for both diagonals, just equal halves on each diagonal. Also, what that's going to mean in coordinate planes is that if the diagonals bisect one another, this point in the middle here is going to be a common midpoint between these diagonals. So each of these diagonals, if you find the midpoint of each of them, they're actually going to have the same exact midpoint. So in coordinate plane math, if you find that diagonals share a common midpoint, then that means that the diagonals are cutting each other in half. All right, let's see if we can apply those properties and find an unknown measure in a given parallelogram. What we're going to want to do is take a look at the pieces that are involved in the problem and see which property applies to those pieces. That's going to help us set up an equation that we can use to solve. So for example, in this part A example, we're given side lengths here and we're given opposite side lengths. So we use the property that opposite sides are congruent or equal. So now we can set up an equation that says that these two expressions are equal. And then we can use our algebra steps to solve for x. So if we subtract 4x from both sides and subtract 1 from both sides, 3 minus 1 is 2, and 5x minus 4x is x. So x is 2. It's not the answer to the question though. We want to find the length of segment DE here, or the distance between points D and E. So plug your 2 into that expression for DE. So we have 4 times whatever x is, so 4 times 2, and we're going to add 3. So 4 times 2 is 8, plus 3 is 11, so the side length for DE is 11. And that means that the side length for FC is also 11. You can plug it in to check. Plug a 2 in, 5 times 2 is 10, plus 1 is 11. So opposite sides are congruent there. On over to part B. Let's take a look at the pieces involved here. We're given some angle measures, and we're given angle measures of angles that are on the same side. So we're going to use that property that says that same side angles are supplementary or add up to 180 degrees. So we're going to combine our expressions here and set it equal to 180. That's our equation. Let's combine 2x and x and get 3x, and combine 120 and 60 to get 180. If we subtract 180 from both sides, we get 3x equals 0. And 3 times any number equals 0 means that we must be multiplying by 0. You could divide both sides by 3 if you needed to, but we know x value is 0. If we plug that x value back in, that's going to cancel the 2x term, making this angle 120 degrees up here. And if we plug that x value in down here, that's going to cancel the x term, leaving 60 behind. So that means angle S is 60 degrees. Still not the answer to the question. We want to find the measure of angle V. So we could use the other property talking about angles, where we know that opposite angles are congruent. So T and V are opposite from each other. If T is 120 degrees, then angle V must also be 120 degrees. Or you could continue to use the same side angles or supplementary property, knowing that S is 60 degrees, its supplement must be 120 degrees. All right, last example here, part C. Given the pieces of a diagonal, so L to H is half of this diagonal right here, that's 3x minus 2. HN is the other half, x plus 12. Well, we know that the diagonal here gets cut into 2 equal parts. So LH must be equal to HN. So we can set these two expressions equal to each other and solve for x. We're going to subtract x from both sides, and we're going to add 2 to both sides. So over here we get 2x, over here we get 14. Divide both sides by 2, we find that x is 7. Still not the answer to the question. We want to find the length of LH. So we'll plug that x value into the LH expression there. So 3 times whatever the x value is minus 2. 3 times 7 is 21. 21 minus 2 is 19. So the length of LH is 19, which also means that the length from H to N is also 19. Plug in a 7 into that x spot. If the question were instead, what's the length of the full diagonal? Well, you would take your 2 halves, 19 plus 19, or 19 times 2, and find that the full length there is 38 units. All right, so that's how you play around with those properties and solve for unknown measures in a parallelogram. One last thing, a little bit of a challenge here. Given 3 coordinates, or 3 vertices, of a parallelogram, how can we locate a 4th possible vertex? So in this example, we're going to pretend that we were given a treasure map and it was partially ripped. We were given 3 of the coordinates, but that 4th one was ripped off somewhere. So how can we find the 4th coordinate? Well, the first thing we could do with these 3 points is we could set up a coordinate plane here and establish some coordinates so we can see how these 3 points relate to each other location-wise. We could draw that coordinate plane anywhere there. In this copy here, the grids are washed out, but there used to be grid lines here. So that's how I got these coordinates. I didn't just make them up. This y-axis is 1 unit to the left of this point and 2 units, and the x-axis is 2 units away. This x-axis was 1 unit above these points, and this point was 3 units to the left, this point was 3 units to the right. So there used to be grid lines there, but they got washed out. All right, so now that we know the coordinates here, we're going to take those coordinates, and just for simplicity, we're going to transcribe them onto a nice looking coordinate plane here, so that we can work with it. We get a little bit more room here. So taking -3, -1, plotting it here. Taking 1, 2, plotting it there, and 3, -1 right here. So we know these 3 points, and we're going to try and find a 4th possible coordinate. Well, since we know that in a parallelogram, opposite sides are parallel, And also knowing that parallel sides have the same slope, we can use slope to determine where our fourth possible vertex is. So for example, if I want to try and find a fourth corner here for this parallelogram and make a parallelogram right here, I know that this side has to be parallel to this side, so the slope between these 2 points must match the slope between these 2 points. So to get from this point to this point, if I go left 2 and up 3, I can just copy that over here, left 2, up 3, and there is one possible vertex of our parallelogram. It's not the only option though. Another thing we can think about is notice that vertices are opposite from each other. So this first vertex that we found was opposite from this corner. If we just think about that and find a fourth vertex that is opposite from one of our other 2 points, then we could find another location. So let's say we want to go opposite from this corner. So we're going to have some coordinate over here. We know that this side right here is going to be parallel to this side. So let's find the slope between these 2 points. We're going up 3, right 4. So let's repeat that. Up 3, right 4. And we found another location of a possible vertex. One more time. We haven't found the opposite vertex of this point yet. So we know it's going to be somewhere down here. Now we think we might want to find a side that's parallel to these 2 points. So let's find the slope between those. We go down 3, right 2. So let's copy that slope over here, go down 3, right 2. And there's our final third location that's possible. So now we have this parallelogram. So how do we know that we're done? How do we know we found all of the possible locations? Well, similar to what we just discussed. We know that vertices are going to be opposite from each other. If we have 3 corners here, well then we must have 3 possible locations of a fourth vertex, each being opposite from one of these 3 points. So anytime you're trying to find a possible location of a fourth vertex in a parallelogram on a coordinate plane, all you have to do is use slope, and remember that there's going to be 3 options. Each of them are going to be opposite from one of the given coordinates. All right, so good luck practicing parallelograms and learning those properties.